saya menjemput YB Datuk Bandar untuk merasmikan JWDB. Silakan.
Project is applying to a principle of Pascal. So what is principle of Pascal? So basically, Pascal principle describes the behavior of fluids in enclosed system. So when the pressure is applied to a confined fluid, the pressure change is transmitted equally in all directions. This means transmission of pressure occurs undiminished, meaning that the magnitude of pressure change remain the same. So basically, there are three main objectives of our project. So firstly, to provide a route for pedestrian, vehicle and any other transportation to cross over a barrier such as a river or sea. Secondly, to ensure that the drawbridge can be raised and lowered efficiently to minimize disruption to both vehicle and marine traffic. And lastly, to create a reliable infrastructure that operates efficiently, minimizing disruption to transportation flows.
Our project, the hydraulic bridge that made out of a cupboard that involved Pascal, theory, and hydraulic system, involves several steps. And the first part of the process is design planning, in which we sketch out the bridge designs while considering factors like size, weight capacity, and the aesthetic of the bridge. And then we move to the second part of the process, which are the materials gathering. In this process, we collect sturdy cardboard as needed, glue, hot glue gun, scissors, rulers, markers, and most importantly, the shrinks and tubing, as well as other materials. Then moving on to the construction part, we cut the cardboard into the appropriate shapes based on our design plans for the bridge components. And after finishing the cutting part, we assemble the pieces using hot glue gun to create the bridge structure. Move on to the hydraulic system, which is the most important part of the project. We design and install the hydraulic system using 4 shrinks and 2 tubes with the same length, and also the colored water. These systems will allow us to raise and lower the sections of the bridge as we needed and wanted. And last but not least, we move on to the last part of the process, which are the testing and refinement part. We test the hydraulic bridge to ensure that it functions properly, and we also made some adjustment as needed to improve our bridge stability and performance.
There are 3 functions of hydraulic bridge models. Firstly, the model is crucial for evaluating different bridge configuration and assessing their stability under various water flow conditions. Next, hydraulic bridge models helps engineers to understand the complex hydraulic forces acting on the bridge structures, including pressure distribution, flow patterns, and potential erosion. Lastly, hydraulic bridge models plays a key role in assessing the environmental impacts of bridge construction and operation on the water flow patterns, sediment transport, and aquatic habitats. However, there are few limitations of hydraulic bridge models. Firstly, scale effects. Scaling down real-world bridges in hydraulic models can introduce inaccuracies due to scale effects, impacting the model's ability to accurately represent full-scale behavior. Next, hydraulic accuracy. Achieving precise hydraulic conditions in hydraulic models can be challenging, leading to discrepancies between simulated and actual flow patterns and forces. Lastly, testing limitation. While hydraulic models can simulate a wide range of hydraulic conditions, they cannot replicate all real-world scenarios, such as extreme flood events or dynamic interaction with surrounding infrastructures.
Next, I will be talking about the contribution that this model has made to the society. So the first one will be transportation improvement. If successfully implemented, the hydraulic bridge could significantly improve the transportation between Johor Bahru, Malaysia and Woodlands, Singapore, potentially reducing travel times and congestion on existing roads. And the second one will be economic benefits. Enhancing connectivity between 2 major cities could stimulate economic growth by facilitating easier movement of goods, services, and people, leading to increase of trade and investment opportunities. And the third one will be social integration, which the bridge could promote social integration by bringing people from different communities together, fostering cultural exchange, and facilitating social interactions between residents of Malaysia and Singapore. In conclusion, the Hydraulic Bridge project aims to provide efficient and reliable transportation infrastructure, enabling seamless movement of pedestrians, vehicles, and other forms of transportation across barriers like seas or rivers. By ensuring efficient operation and minimal disruptions to both land and marine traffic, the project not only enhances connectivity between Johor Bahru, Malaysia, and Woodlands, Singapore, but also stimulates economic growth, promotes social integration, reduces environmental impact, and contributes to technological innovation. Overall, the project has the potential to significantly improve the quality of life of residents of both cities while advancing civil engineering and infrastructure development.